Hi, good morning, everyone. I'm excited to talk about an interesting topic, revolutionizing campus networks, cost savings, and advanced capabilities with merchant silicon. And as a part of this discussion, I just want to briefly introduce my colleagues. They can say a little bit more about themselves if they'd like to when we transition to them. Felix from Dartmouth, he's the Chief Technology Officer, so he's here to talk about some things from Dartmouth's perspective. My boss, Charlie Kneifel, is the CTO from Duke University. And Paul Schmidt is a network architect from Dartmouth, and I'm a network architect for Duke University and Health Systems. So we're excited to discuss this with you today. So we're going to break up the presentation into some general sections. We'll talk about sort of what are we talking about here in terms of merchant silicon, who are the players, why would this be interesting for research and education institutions, what are some of the challenges and next steps. So to kick us off here, we'll talk about the what. And as a part of that, we have a brief review of traditional architecture and software-defined networking, and then we'll talk about commoditization and briefly introduce Sonic, which is an open source network operating system. So, just to sort of level set and make sure we're all on the same page here, we just wanted to provide a brief review of traditional network forwarding elements. So historically, you would buy these from a vendor, and they would use open standard protocols, but essentially what was happening inside of the device itself was usually proprietary. So you might have the management plane, the control plane, and the data plane, and again, maybe the control and management plane are using open industry standard protocols, but the integration between the management plane, the control plane, and the data plane was oftentimes proprietary. And software-defined networking changes some of this, which is pretty exciting. So all the way back in 2008, there is a paper from Stanford University that introduced OpenFlow, and that was sort of an interesting concept to say, how can we abstract the way the data plane would be managed? And it developed this pipeline of tables architecture where you could specify match and action fields to allow external software to control forwarding. But there's also been a lot of other approaches to SDN that have come out as well. One of the ones that's really interesting is overlay networks. This is kind of interesting to think about. If your network has become ossified and you can't change it anymore, how are you supposed to innovate? One way is just to build virtual overlays on top of the existing network and then do your innovative things within those overlays. So as a part of that, there's some interesting protocols that are out there. VXLAN and Ethernet VPN are the ones that we've highlighted that we see a lot of possibility for the future. But there's also one other approach to SDN. This has actually been around for a while, but it's only started to gain a lot of momentum more recently. This is the switch abstraction interface, and this is a way to say, how can I take my proprietary ASIC and expose sort of an API to that to allow other applications to program the forwarding tables in that ASIC? So this is a C API, and this is key to what makes a lot of these open network operating systems, including Sonic, work. So we'll talk a little bit more about that throughout the presentation. And as time has evolved, it's important to note that a lot of network forwarding elements are starting to become more commoditized. So there's a lot of merchant silicon vendors that are out there now, so Broadcom, Marvell, for example. And what would it take to sort of take those ASICs and put it into a switch chassis and then allow you to choose what network operating system you want to run on that chassis, and then what would it look like to use the switch abstraction interface to develop some custom forwarding paradigms on those chassis. So this has all started to come sort of to the forefront initially with the hyperscaler cloud computing environments. They wanted to have custom forwarding, they wanted to use merchant silicon, they wanted to use an open network operating system where they could only have the protocols of interest on there. And over time, sort of that has evolved. There's a whole variety of open network operating systems and closed network operating systems that you can run on these commoditized devices. But one of the ones I think that's most interesting is called Sonic. It stands for Software for Open Networking in the Cloud. It was originally developed by Microsoft for use in Azure, and it's now a Linux Foundation project with a lot of contributors. It's kind of interesting to see how it works. It uses the Linux kernel, and then essentially on top of the Linux kernel, there's a variety of containers that run to provide various network services. So routing protocols, management protocols are all containerized. If you wanted to add a new capability or service, you could install your own container. The other thing that's pretty neat about it is this ONI bootloader that supports the loading of a network operating system of your choice on a merchant silicon switch. But even if you did standardize on SONiC, ONI provides a lot of interesting capabilities. For example, zero-touch provisioning to allow you to automatically install SONiC, the version of SONiC that you want to use, and then also you can use automation to install essentially a baseline configuration file. And so while all of this might look complex to have all of these containers running on a Linux kernel and sort of creating a network operating system through the composition of these services, it's important to note that essentially the startup config is in a plain text file. So if you're used to classic network operating systems with a startup config, there's parallels here as well. So with this high-level overview, I'm going to turn things over to my colleague Paul to talk about who are some of the players and what are some of the products.
So I'm Paul Schmidt, network architect at Dartmouth, and just sort of to highlight here, both of us were Dartmouth was interested in what Duke presented last year when they were presenting about SONiC, and we've always thought that going to an open network operating system would be an interesting choice for a next evolution. So we've got in touch with Duke and we're working together and trying to figure out how to explore this space that is SONiC, because SONiC's a little bit different from what you're used to dealing with. If you're used to dealing with Cisco or Juniper, like you have an actual vendor to go to and they have a product to offer you. If you're looking at a switch abstraction interface, how do you actually turn that into something that you're going to actually run your network with? So looking at community SONiC, that's the version of SONiC that came from Microsoft that has these features out there that are open source. You can go to the GitHub. You can see what the features are that exist in community SONiC. But because this community SONiC is out there and people can modify it, lots of people have done that. So you look at different versions of vendor SONiC, which might add on features that don't exist in the community version of SONiC. So on the right side there, I've listed some of the vendors that offer their own version of SONiC. So you have Broadcom, Celestica, EdgeCore, Juniper, Cisco, Arista, and so on. And they all have sort of their own way of modifying SONiC to add the features that don't exist in the community version. So this could be something like MC lag or EVPN or dealing with PoE or whatever. But they've taken the basic framework of SONiC. It has sort of that same concept. You're still dealing with the ONI bootloader, you're still dealing with a master configuration, you're dealing with Linux and containers and how those all get orchestrated, but it lets them add sort of value on top of that. But if we're looking at this from like a consumer perspective, like coming in this from Duke or Dartmouth, going from one version of SONiC to another version of SONiC is a lot easier than going, say, from Cisco to Juniper. So like if we're looking at deploying our next version of the network out to support the campus and support research and all that, if we have the option to move between different versions of SONiC, that's a lot easier than it is doing a more substantial version of moving from one vendor to the other. But if you're looking at SONiC, you sort of want to approach it as, I'm choosing a Linux distribution. You won't say, oh, I'm running Linux. I mean, you could download the Linux kernel and do all your modifications and build all your programs in that you want, but most likely you're running Red Hat or you're running Ubuntu. And that's going to be more akin to what the different vendor versions of SONiC are that are out there. So you sort of have to choose, what are the features that are important to me, what does the vendor provide to me, and then choose an option on how you're going to approach deploying SONiC. So just to take a couple examples that we've investigated, this isn't to recommend them, but this is just to sort of say, these vendors are out there, they're just as valid as Cisco or Juniper on actually supplying a full product line of switches and routers and having good features there. So Celestica started off as a manufacturer, and they are actually an OEM that makes a lot of switches, say, for Cisco and Juniper. And they've come out with their own product line that they're offering to run SONiC. So that you could run community SONiC, or there are two different versions of Celestica SONiC that you could run. Looking at things sort of from the low end, you have your campus switches, which would just give you, say, gig ports or mgig ports, as well as support for PoE. You can see that the actual hardware price is just under $4,000. It's fairly cheap for a switch. If you're doing this at scale, like those numbers add up. And I'll emphasize that this is list pricing. If you're buying 1,000 switches, you're going to get a better deal than what the list price is, just like you would from Cisco or Juniper. Then you move up sort of in the world and you've got SFP 28 ports, so you can do 10, 25 gig with 100 gig uplinks. Again, fairly modest price at like $5,000 a switch. But just to emphasize too, these are built on Broadcom, so like you're dealing with the Broadcom SAI, you're dealing with all the features that you would get there from a Trident chipset. You're going to get support for EVPN. You're going to get support for what you would get now from a traditional switch vendor still in there. And you're going to make sure that like the version of Sonic that Celestica is supplying you, or whatever you're running for, if you were running Community Sonic, is going to support the features that are available in this chipset. You can move up even to, say, 3200 gig ports, looking at just over $6,000 for a switch. Like, I mean, the reason that this is really sort of revolutionizing your network is if you have a spot that you're behind on in your network, whether it be the core or aggregation or your edge devices, the cost for upgrading these devices is not enormous. As well as you can move up to 32 400 gig ports for just over $10,000. As well as you can do the 800, which is 2x400 on a single port at 32 ports for about $25,000. And again, with full EVPN support. As well as there are some upcoming products which we're particularly interested in that are geared toward Wi-Fi 7, dealing with full PoE on ports, providing both 10 gig copper as well as M-Gig for good uplink speeds on your wireless APs. Also supports full MACsec encryption, full EVPN, and less than $7,500 per switch. As well as you can go look and see these other 400 gig and 800 gig for about $10,000 for a switch. Looking at one of the other big players out there, EdgeCore is based out of Taiwan. They've been around for quite a while and have contributed a lot for Sonic. There's again multiple options that you can run on the EdgeCore devices. You could run Community Sonic, the EdgeCore Sonic, or increasingly they're pushing people toward Broadcom Sonic. But again, also you can get software support from them, tier 1, tier 2, tier 3 escalations to deal with any problems that you might be running into. And again, you'll see the same general types of Broadcom switches that are out there, dealing with 1 gig ports, with 10, 25, or 100 gig uplinks, with EVPN support, or you might go up to like M-Gig with 10 gig copper, and so on. It's a full product line out there that you could go with several different vendors to get good switch support. So now sort of looking at the why would you actually want to make this move? From a vendor perspective, if you're looking at traditional vendor like Cisco or Juniper, about 50 to 60% of their revenue is coming from campus deployments. Whereas with Sonic, it's about 1% or less of their revenue is coming from campus deployments. They've got a huge financial incentive on actually giving us products that we want to use out for large deployments. If we're looking then next, the chipsets that are out there that are supported in the hardware, you get the like Rocky V2 overlay networks, EVPN, as well as with vendor versions of Sonic supporting PoE, .1x, things that wouldn't have been traditionally associated with data center deployment. And then finally, with Sonic, there's no licensing cost beyond what you're going to pay for support from your vendor. Looking at the vendor versions of Sonic out there, you can get full features without actually having to do licenses. And if you look at how that might change your network design, like I have the current Dartmouth network design was designed with about 20 EVPN devices because doing it for 1,000 was way too expensive. But doing something where you don't actually have to worry about the EVPN licensing costs, you could come up with something completely different. Okay, so next, Charlie.
So a little bit about what really is driving us at Duke. We have two separate networks because we have a health system, all that yada, yada, yada. But in our data center, we have 110 switches and routers. Facilities-wise, we have 1,600 switches and 120 routers. They support 9,200 wireless access points, and we have somewhere around 2,000 cameras on that network. Those APs and those cameras do one thing. They hit the switch, and they go back to the middle. So in our model, they are easy targets to replace with a commodity hardware in a stack in the closets and lower our costs significantly. The health system has similar things with 8,200 APs, so their drivers are very similar to ours. So simplifying even just those two portions of our network, cameras and wireless access points, would really be useful. Dartmouth has a similar networking in terms of the size of the data center and more comparison on the size of the APs and the switch infrastructure to support them. And so as we start to think about the networking pieces here, this is our bypass network?
This is just saying essentially if
Okay.
use commodity versus merchant.
I need to wear my different glasses. Yeah, we're comparing what is our sort of the price for the edge stack here, and we're looking at a 90K list versus an 18K list. So even if we get really good discounts, which is going to be cheaper? And then our overall savings estimates on this, if we did everything that we could save $8 million a year. That's money even to Duke. We don't have to spend it on football. Yeah, even if it doesn't get us an invitation to the big dance, and about $4 million for Dartmouth in the same space. And then, Paul? This is you?
Yeah, sure. Yeah, and so looking at Sonic, as Will was mentioning before, it's really built with automation in mind. Rather than having 1,000 network devices, now you have 1,000 Linux systems out there. And if you're automating them with Ansible or whatever your automation platform might be, it's really well suited for that. Now also, since you're running a full Linux device, like you can deal with actual processes maybe that the box would go pull for changes. Do I have any changes? Do I need to apply them? Like there's a lot that you can do once you can actually do all your automation on your network switch. So sort of sky's the limit on what you can come up with. So looking at some of the challenges, looking at Sonic, sort of the, and what you're running for your switch, hardware is only part of it. You do have the control plane, you do have actually programming how you want your switch to work. So if you're looking at a vendor version of Sonic, they're probably going to be able to offer you more features than you would get in the community version of Sonic. So it's important if you're out there looking for a vendor, find a vendor that's going to contribute back to the community. You want to see those changes that they're making actually propagate out so that everyone can take advantage of it. Other thing is that making those changes actually back into the community version is not necessarily straightforward. There's the sort of the Sonic implementation, but that relies on the Linux kernel, it relies on FRR, it relies on all those containers that are running, so whatever's running DHCP or PoE, and getting all of those services to talk together. Your change maybe to support a feature in EVPN might impact like 5 of those, and getting all those changes actually out into the upstream sources may take a little while. So you're going to get faster implementation of features that you care about, probably going with a vendor version of Sonic rather than running your own out of community Sonic. But then also, testing is going to be really important, but with the amount of money that places are poised to save, building out a decent lab seems like it should be quite doable. So again, taking PoE as an example that doesn't yet exist in the community version of Sonic. I'm going to sort of gloss over this, but like Celestica, EdgeCore, and Broadcom, they all have their own version of how they want to do PoE. And there's a feature to add PoE to the community edition of Sonic, but it's sort of yet to be determined on like which version is going to be adopted. Is this going to make it back into the other versions? Anyway, it's a little complicated, but like progress is being made on making sure that these features that we care about from a campus perspective are making it in there, and it's not just focused on the data center.
Excuse me. I was getting over a cold, and then the dry air of Colorado was just not the greatest thing of that. So I wanted to talk a little bit more about support in kind of this scenario, because as network engineers, it's really, really tempting to think of support simply as, right, like that's, you've got your engineering tiers 1, 2, 3, and then support is who you might call if you can't solve it internally. And that's one way to look at support, but organizationally, from the perspective of like a university or a lab, really this is like an external risk transfer, right? Like support is not only there to help you out of the hole, but it's also, might be distasteful to some, to point a finger or say, I've got this sort of coverage, and to kind of sign cybersecurity insurance policies, et cetera, right? Like that's something you have to account for. So just like any other time that organizations like ours deploy open source, even if we're buying from a vendor, it is kind of important to make sure that what we have and what we're getting for support is lining up with the total risk appetite that the organization has. And networks are extremely critical, right? If we're talking about campus networks specifically, at least at Duke and Dartmouth, they run life safety. We send people home when networks are down in buildings, right? They can't get any work done. So it is really important that this stuff is up and running. So I do think there's an opportunity here, like Paul said. Sonic is popular in large data centers. They have, like this is something that has been shown to deploy at scale, but for campus networks, that is where growth can happen. So I do think within higher ed in particular, where our risk appetite maybe is, you know, we're not hungry to go and get screwed on something, but we have more risk appetite than a .com quite often. So there's a chance here to partner with some of these vendors and try to build something. And then the last thing for our presentation is just next steps. So we would like to see if any other people in the community here are interested in doing this sort of thing. We are, I think, going to try to replace, say, wireless stacks for this, because if all an AP needs to do is get a DHCP address and, you know, be able to send traffic for its data plane somewhere, that's a really low feature bar to hit. And the savings are pretty extreme, as was shown. So we're interested in if other people here would like to do this, if you'd like to share experience, if you'd be interested in testing things, and whether you'd like to integrate with anything we're building. There are some resources here. There is a great wiki that can get you up to snuff on what Sonic is. There's a Slack channel that we are currently using to kind of cooperate. We'd be happy to invite other people to. We have a Zoom meeting every 2 weeks where we kind of update each other, and just reach out to Paul if you want to get involved. Any questions? We were comprehensive enough. Thank you. Oh, sorry. Yeah.
Hi. Did you have any trouble with buy-in from leadership going in this direction, or did kind of vendor being in the mix help, the word vendor?
Not so far, where I will say, I think this is true for both institutions. We've not yet basically said, hey, let's replace the whole thing. This is we're testing stuff. I do think we're lining it up, particularly with this view towards like, how would we get support? Right, like it's a lot easier to buy this from a company that has like 14 billion with a B kind of revenue, right? Where you can kind of say, there's something behind this. This may not be a name you know right now, but I can point you to a wiki page where you can look up that this is real, then some 2-3 people in a garage, right? And you're right, the reality is that's something you need to take into account if you want to sell this.
So, do we have time? Okay. Well, quick question about automation. Are you using this in situations where automation is not super important because things are fairly simple and straightforward?
The opposite.
The opposite. Okay.
Yeah, so at least at Dartmouth, our network is 100% deployed through automation. In fact, any change you make on the command line will get overwritten at midnight from the source of truth, and this will get deployed with that in mind. Sonic is, it's interesting. It is, in theory, extremely automatable. Ansible can work with this really well because at the end of the day, this is Linux. And we have figured out how to mass manage tens of thousands of Linux boxes.
So in general, your Ansible is only as good as the providers and the things that are set up that the community is driven.
Yep.
So how easy was it for you to kind of slot in this new, to switch to Sonic and to switch your automation? Was that a big lift or was that fairly straightforward?
That was so far fairly straightforward, in particular because providers, etc., are important when you're dealing with network operating systems where Python isn't on the box, right? You need to do all this crazy stuff because Ansible wants to just SSH you into a box and run Python.
Right.
Well, these can. So these are really very different to automate compared to other switches.
Okay, thank you very much.